Okay, for algebra today, you need your packet. Hopefully no one has lost this packet. It's very important. And we learned lesson 1.1 Monday, we did 1.2 Tuesday, and we did 1.3 Wednesday. So it is time for us to look today at 1.4. So in your packet, go ahead and open up to the very first page that you see 1.4, and I don't know why there's a 0, but 1.04. So turn in your packet. We already did all of this, even though we did it on Amplify, not in your packet. Okay, here it is. So your first page should look like this. 1.04. It says additional practice, but that's because we did not do the Amplify version. We are doing the notes packet version of this lesson. Okay, the first set of boxes just says determine whether each sequence is arithmetic, geometric, or neither. So remember, arithmetic is when you're adding or subtracting. Geometric is when you are dividing or multiplying. I should have put multiply first. Doesn't matter. And then neither. So here we go. From 3 to 10 to 17 to 24. This is clearly adding 7 each time. So if we're adding 7 each time, that is arithmetic. I'm going to abbreviate it. If you want to write it all out, you can, but I write too big, so that's not going to fit. Okay, the second one, from 1 to 10, 10 to 100, 100 to 1,000. We're adding a 0 each time, which means we're multiplying by 10, which means if you're multiplying, it is geometric, geo. From 12 to 6, 6 to 3, 3 to 3 halves, which is 3 divided by 3. That should be your hint. We went from 3 to 3 divided. A fraction means division, divided by 3. So clearly we're just divided by 2. We're clearly dividing by 2. 6 divided by 2. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 2. So this is divided by 2. But you can't really write it like that. I think we already talked about it. We won't be dividing technically. In geometric sequences, it's always multiply. So in order to divide by 2, you're actually going to multiply by half. So half times 12 is 6. Half times 6 is 3. Half times 3 is 3 over 2. So, okay, so that would be multiply, which is geometric. All right. 1 to 4 to 9 to 25. Do you know what I think this is? I think it's like 1 squared is 1, 2 squared is 4, 3 squared is 9, but then it jumps to 5 squared. I'm going to say this one, I cannot find a pattern. This one is neither. If you guys find a pattern, tell me, but I'm not off the top of my head seeing one, and one of our choices is neither, so we're going to put neither. All right. Complete the arithmetic sequence. So since these are all arithmetic here, you know you're just going to be adding or subtracting every time. In fact, you know what? You guys have done this already. This should be very easy. So would you mind doing me a favor and pause your video right now and then try these all 5 on your own. I know you know how to do it. You'll know what number is next. Fill in the blanks. We've already done Delta Math like this. So you guys should already know how to do this one. So press pause, and then when you're done with A, B, C, and D, press play and check your answers. Okay, I'm just going to fill these in so you can check your work. These should have been 2, and I'm doing this really quick, 14. I hope I don't make any mistakes, but clearly this is just plus 6. The next one would be 114, 314. All you're doing is adding 100. For C, it would be 3, because it looks like you're adding 1.25, which means this one's 6.75, and this one would be 8. For this one, we're subtracting, but again, you don't really subtract either. You only add or multiply, but you can get away with subtraction by putting negative. So it's technically negative, what, 10, negative, what would that be? 5. You're just subtracting 7, right? Minus 7, yes. Another minus 7 would be negative 16. Okay, Go ahead and do the same thing now. We're doing geometric sequences, so this time we're multiplying. And if you think you're dividing, you're actually multiplying by a fraction. So go ahead and push pause and try to fill all of these in too. Okay, I'm going to do this really quick to make sure that you guys have already done this. These look like they're just times 2, so that would be 40, 160. Okay, this one, ooh, so 12 to get to 3, I think it's half and then half again and then half again. Yeah, so the pattern is times half, so that would be 6, and then either 1.5 is fine, or 3 halves is fine. Either way, if you put 1.5, that's the same thing as 3 halves. You're just dividing by 2, so I just put divided by 2. C, looks like from 4 times 3 is 12. So times 3 again would be 36. Times 3 again is, I think, 108. And then if I work backwards and divide by 3, well, we'll just write it divided by 3. So 4 divided by 3 for 4/3. If you wrote like 1 point, I think it'd be 3 repeating. That's fine, but it's more accurate to put a fraction because then you're not rounding it. It's exactly what it is. Okay, and then in the last one, looks like that's times 5. So times 5 again would be 625. Working backwards, 625 divided by 5, divided by 5, divided by 5 would be 5. Okay, let's turn the page. Sometimes you will see patterns, sequences set up in a table. So I don't think we've really seen this before, but it's not any different than what we've been doing. This is the first term, second term, third term, fourth term, fifth term, and this is your pattern. So the first one, we want to know what type it is. So is it arithmetic, geometric, or neither? What is the first term? Actually, that's going to be easier. So let's go ahead and write what the first term is. The first term is -2. So our first term is -2. And then we're going to write what the rule is. So let's figure it out. From -2 to 5, they added 7. From 5 to 12, they also added 7. So as long as that's the pattern the whole way, we know it's arithmetic because it's addition. So the type is arithmetic, and the rule is add 7. I should write to the previous term, but that's what the rule is. Add 7 to the previous term. So you know where to start and you know what the rule is. Okay, when you see it in a graph, it's a little bit harder to see right away, so I'm going to give you a little shortcut that I think will help you. It's always helped me. I'm going to put what that coordinate is. So if I were to put an x and a y coordinate on this dot, it would be over 1, up probably 1, because all the way up to here is 5. So I'm going to say it's probably 1, 1. So I'm going to just guess for now, but I feel like that's probably right. Okay, let's put a coordinate on this one. This one's easy because it's right on a dot. So we know it's 2, up 5. So 2, 5. So let's write what that ordered pair is. 2, 5. And then 3, 25. So 3, 25. Okay, now that you have the ordered pairs written, you can pretend it's written in a table just like this. The first term, the second term, the third term. The first term is 1, the second term is 5, the third term is 25. So what's the pattern to get from 1 to 5 to 25? So that makes it a lot easier to see that all we're doing is multiplying by 5. So the type is definitely geometric because we're multiplying. The first term is 1, and the rule is multiply by 5 to the previous term. Okay, I hope that makes sense. It makes a lot more sense whenever you put the coordinates on it. In fact, let's do the same thing on this next one. So this dot up here is over 1, up 4. So we're going to write 1, 4. This dot is 2, 2. So 2, 2. This dot is at 3, 0. And then this dot down here is at 4, -2. 4, -2. 2. Okay, so this is our first term, second, third, and fourth, and the pattern is going from 4 to 2 to 0. I was going to say you could half it, but then you can't half 2 and get 0. Half of 2 would have been 1. So we're not halving. 4 to 2 would be minus 2. 2 to 0, minus 2. 0 to minus 2 is negative 2. Okay, so this one is just subtracting 2 every time. So that means the type is it's arithmetic. The first term is 4, because at 1 we had 4, 1, 4, so the first term was 4. And the rule is subtract 2. Okay, I'm going to give you a really big tip that if this sticks in your brain right now, it will actually help you down the road. If the type is arithmetic, it's going to form a straight line. So anytime you have adding or subtracting, it's going to be perfectly straight when you draw lines through it. Okay, that wasn't. But anyway, if it's geometric, it's going to have some type of a curve. So either up or it might curve down, but it's going to curve. So geometric, so we should have already known right off the bat it was going to be geometric because it's curvy, and we should have known this was arithmetic right away because it's linear. It's more of a straight line. All right. Down at the bottom, it says we are going to circle in this first box, number 7. We're going to circle if it's arithmetic, geometric, or neither. So we'll circle arithmetic, geometric, or neither. And we're going to write the first 4 terms of each sequence. So first term is 2. So let's go ahead and write 2 because that's our first number, and we have to write the first 4 terms in each sequence. And the rule is to multiply the previous term by 4. So 2 is our previous term, times 4 would be 8. 8 times 4 is 32, and 32 times 4, use your calculator, I think it's 128. Man, I hope that's right. Okay, and then since we're multiplying, it is geometric. So if we were to graph this, it would be curved. Okay, I tried this one. You guys try numbers 9 and 10. Go ahead and pause the video and try it, and then you can check your answers. All right, so first term is 1. They want the rule to be add 1 to the previous number, and square it. So we're going to add 1, which would be 2, and then we're going to square it. And square it, squaring 2, 2 times 2, 2 squared would be 4. Okay, we're going to add 1, which would make it 5, but then we're going to square it. So 5 squared, 5 times 5 is 25. Add 1, which is 26, and then square it. I have no idea what 26 squared is. 26 squared is 676. And I'm sorry to tell you that that is neither arithmetic or geometric. It needs to be a constant just multiply or just add in order to be one of these. You can't say add and then, by the way, also square it. That rules out either one of these two. So this is neither, even though we can figure out the pattern, because it's these two different things and one of them is squaring it, this is going to be neither. That was tricky. I shouldn't have made you guys do that one on your own. But there it is. Okay, number 9. The first term is negative 12. So the first term is negative 12. The rule is we're going to add 4. That's literally all you have to do. Add 4. So negative 12 plus 4 is negative 8. Negative 8 plus 4 is negative 4. And negative 4 plus 4 is 0. If you are adding, that is arithmetic. Okay. Turn the page to the last part. Let's take a look at our show what you know. So this is kind of like your, I would call it like an exit ticket. This is kind of your ending, like when we've done it on Amplify before. This is I will check it and then you can go work on your Delta Math. But since we're doing this on a video, you get to show what you know, so you can just try it. I will read the directions with you and let you get this figured out. So determine which sequence on each card is arithmetic. Determine whether, each card is arithmetic, geometric, or neither. So card A just has a table. So you just need to look at it. First term's 400, then 40, then 4, then negative 4, then negative 40. I'm going to go ahead and tell you right now that's dividing by 10 every time. So, wait, is it dividing by 10? No, it can't be because, dividing by 10 wouldn't give you a negative. 4 divided by 10 would be 4/10. So this, they got to be doing more than one thing because you can't also subtract either. So this one is going to fit under neither. So card A is going to go under neither. All right, let's go ahead. You know what? Let's just do this one together. I was going to have you guys try these on your own, but after seeing card A is neither, let's make sure you know how to do this. Or if you want to, you can pause the video and try the rest on your own. Card B, it looks to me like card B is multiplying by -2. 3 times -2 is -6. -6 times -2 is 12. 12 times -2 is -24. So this one is multiplying by -2, which makes it geometric when you're multiplying. So this is a geometric one. Okay, done with B. C just doesn't have a table, but it just tells us the first term is 1, and you're adding 27 to the previous number. So if you're adding and that's all you're doing, that is definitely arithmetic. So card C is going to go in arithmetic. All right, card D. I'm going to have to put the dots. So this is at 1, -6. This one is at 2, negative, in between -2 and -4 would be -3. So 2, -3. This dot is at 3, 0. This dot is at 4. In between 4 and 2 is 3, so 4, 3. And then this one is going to be at 5, 6. Okay, so this is just our first term, second, third, fourth, fifth. Let's look instead at this one, which is the pattern. So we're going from -6 to -3 to 0 to 3 to 6. We also knew it was arithmetic because guess what? It's a straight line. It's a straight line, so we knew it was going to be arithmetic, but I just double checked it and they're just adding 3 every time. So definitely arithmetic. All right, last one, card E, definitely not a straight line. It curves. And just to make sure you would get this right, this is at 1, 1. By the way, that looks like a -1, but you know that going up, they're positives. I think what this is it was just supposed to be where the line was drawn in. So it's not a negative. It looks funny, but it's not a negative. This is 2, 2. This is 3, 4. And this is 4, 8. Okay, so we know it's not adding. We're not going from 1 plus 1 because that would be 2 and then that would be 3. So we're not adding. We are times 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. This is definitely geometric. Okay, you guys, if you want to rate how you think you understood this lesson, you can. But that is up to you. Otherwise, you can go work on your Delta Math right now.